Hi guys. So I started learning Rust a few months ago as a total beginner, and it has been going well, although it's a bit slow because I have other things that take much of my time during the day and sometimes after close of work. So I will be posting videos once in a while of what I do, what I learn. So this is going to be probably a long video because I will be writing the code manually and also be talking, telling you the why, the what, and every other important detail. So this is for beginners like myself, and I hope it makes sense to whoever comes across this video. So as you can see on my screen, we are going to be building a simple program, but it encompasses a lot of concepts in Rust, especially fundamental concepts. So it shows how Rust is good for error handling and the syntax, what needs to be done for one thing to work. Okay, so this is part of some of the projects I wrote out to build, but because I have built like the third one, I think I have gotten more confident. So we are going to just start with this. Like I said, it's a file replacer. It takes a file, set string, and a replacement string. So it reads the file and prints the contents with every occurrence of the set string. So if we have hello Adam. So if you pass arguments to the function and say okay, check this file. The file could be output.txt or whatever, probably .txt. Search the file wherever you find Adam, you replace it with maybe if. Yep. So it does not replace the original file, it just prints a new output but with the replacement. I know this is going to make sense. Yes, it's supposed to make sense. So I am going to start very fast. What I have here is a comment. So this is an error because we don't have any main. So let me just, I had to do this because I don't want distractions. Okay, so let me just push this. So our focus will be here. So first of all, we need to write our main. Okay, so once we have our main and maybe something here, the error will disappear. You see, that's how troublesome Rust can be. So first of all, this program needs us to get the arguments from the command line. Yes, so here is our command line. Let me just start this right. So this is the command line where you do the cargo, your terminal where you do the cargo blah blah blah, right? So now let's start. First of all, we need to read the arguments or the inputs from the command line, which is your environment. And Rust has a standard library that carries most of these very useful modules. A module is a collection of related functions, right? So let's say, for example, you have a room as a module. So the room might have a table, a chair, a bed if it's a self-con, a kitchen, a bathroom. So it's just a collection of related functions. We'll get to that when we start moving on. So first of all, let's say arguments. Let's create a variable called argument, because this is where the inputs from the command line will be saved, right? So this is because we want to add a notation. So the arguments we'll be getting will be strings. Yes, you know what string is? The one that has the data on the heap, not the reference on the stack. No, string. So we'll be saving these arguments in a vector. Okay, so it's going to be a vector of string. So a vector is a collection, multiple datas. So if you look at you can see it's a contiguous global array type written as vec_t. So the t is whichever type you decide to put in the vector. So I have decided mine is going to be string. So arguments vector string equal, where are we getting the argument from? The environment. So we are going to use the standard library. So we going to say env, right? So if you hit enter on your laptop, it's going to call import the module. So if you hover over here, this is like a folder. That's why you see create a folder where all of the modules of the standard library are saved or kept. I don't want to go into much detail, so this video is not going to be extremely long. So if I'm using the Z IDE. So if you hover over the env, you see this is a module, mod, right? It contains functions to inspect various aspects such as environment, variable, process, argument, directory, and other important directories. Like I said, that's what the module is. The environment has functions. So if you want to access more under it, you see these are them, right? They are functions. That's why you see these two open and close brackets. Are they brackets? But let's leave that for now. So we call the environment module, and then we need the args method, right? So if you hover over here, this returns the arguments that this program was started with, right? So if we say cargo run, we are just running the program, okay? But when we say cargo run hello.text Adam, so we are starting this program with these details. That's why the function here reads or collects them from the command line, right? So now, because this returns this argument, we are going to use something called collect. Now we are saying okay, so this transforms an iterator into a collection. So because these are arguments that we are getting from the command line, we want to put them somewhere. So one of the collections in Rust is the vector. There are other collections, right? But we are going to be using the vector that contains strings. A string is a collection as well. If you look at the information here, you will see more, right? For example, you see vector I32, that's unsigned 32 int. So we are skipping that. Now we have saved this variable or data from the command line into this. Sorry, we have saved the data or the arguments from the command line into this variable called arguments. So if you look at it, you see that argument is of this type, right? So now let's see if this actually works, right? So we are going to use the debug macro and then print args, right? This is args, yes. So it's going to let me just save this and run cargo, run hello mama. Mama. So we have more than two arguments here, you'll see. So we have the name of the program, the folder, the crate. Now this is our first argument. So this is argument 0, this is 1, this is 2. So you have a total of 1, 2, 3 arguments, right? So now this program started with these arguments. Now we are going to move forward, right? So we don't need this. Now that we have somewhere to save the arguments, we need to read the arguments somewhere, like store them, store the file paths, store the search string and the replacement string. So we are going to create a function to do that. This is so we can separate rows. This one is doing something else, this one is doing something else. And I learned something when I get some of these projects to work on. When you see the description of the project, it helps you break down your problem. So takes a file path, a search string and a replacement string. This is one problem, right? Okay, so let's say this function is going to be called build, right? Let's say build. And what does it need? It needs a reference to a string, because these are all strings. They are all strings, so it needs a reference to a string. So first of all, we say file path, right? And it's a reference to a string, str. The search string is also a reference to a string. We are the borrow thing. That's why I see this ampersand. Then the replacement, let's call it rep rpl string str. So this is also a reference to a string. So this is always advised to use this when we are, whether it's a string that is on the heap or a reference. So because Rust has something called the reference coercion, so it's going to convert that string to a reference automatically, and this is very okay because anything comes in, right? Whether it's a string or a string slice, right? So this is not we are not no. So there's a mistake here. That's why I said we're building it manually. This is not supposed to be. So because we are expecting this kind of data, this is a string, a vector of string, we should be expecting, let's say, arguments. Yes, I'm sorry, we should be expecting a reference to a collection of strings, right? Yeah, a reference to a collection of strings. Yes, that's what we are getting. And then what does this function promise to return? It's going to return the arguments we pass from the command line. So let's put these arguments together. This is where the struct data type comes in. You put related data together. So the 5 parts, set string, replacement string, those are all related. So we will create a struct, right? Let's call it config, the configuration of our program. We say 5 parts, which is one of the fields, is a string. Okay, sorry. The next one is search. I'm going to shorten it to str. This is string. Replacement. Let me just type it for replacement. This is also a string, right? So this is not coming from anywhere, so we don't need to make this a reference or borrowed value, right? So that's why we have this string. It owns its data. It's not a reference to another data. So now this is this function is going to return an instance of this config data type with all of these fields. So because this can go wrong, so let's say instead of sometimes a user might maybe, instead of run the program with arguments, they run it without arguments. So that is not supposed to happen, or it's supposed to happen. Yes, it's normal. It can be an error. That's why we need to have the result type here, because it could fail. Something might go wrong. Okay. Now, if something does not go wrong and all of the arguments are passed, we we get what? A config type. Yes, an instance of this. But if something goes wrong, then that's an error. Now we return a static string. This one is going to live for as long as the program is running. So static string. This is going to be the error. So if you look at result, you see this OK. This engulfs the error value. Error. This engulfs the OK value. Error engulfs the error value. Right? This is an enum. Almost everything in Rust is built with what we see as the fundamentals: struct, enum, modules, functions, and a whole lot. So now we need to do something which is normal. Let's first of all check, did the user enter the arguments or not? Because this is where we catch the error first. We think about the bad parts before the good. So we are expecting 3 arguments, right? 1, 2, 3, no, 4, because there is going to be the 0. So 0, 1, 1, 2, 3, 4, right? If you count this and the other ones here, this is 4. So we'll check if the arguments are within that range. If args, right? If the length of this arg, if args.length, it's still length, is less than 4, what should we do? Now, if we encounter an error, we expect this to stop. It should stop there. There's nothing else to do. Stop there and return. Exactly, return the error. So we're going to use return because we want the flow to cut. So we return the error. Now, this is what we are expected to do here. The error is going to be a static string, right? So we say invalid or incomplete argument, right? Invalid or incomplete argument. We now have the error covered, but if the error is not the case, now we do what we came here to do, right? We are going to now be storing these variables. So this build is what configures our program, the first stage. So we say we're still going to use this because the names are very clear. Let 5 parts equal. You see, the 5 parts is what comes first. So this is the index 1, args, right? Index 1. Okay. Let's search str equal args. So this is index 2. Let's replace this is wrong. Okay, yes, replacement string equal args index 3. Yup. So these are all of the variables, right? These are all of the variables. Now we need to return these variables. So we have gotten the file path. Yes. Okay. We need to envelop this in the success notation. So there's supposed to be an error and a success. One of them will happen. So we'll say okay. Wrap it inside the okay value. Contains the success value. I can see. The type is config. So the config has 3 fields, file paths, search string, replacement string. So because the names are the same, we don't need to make any changes. Okay, so these have been satisfied. So but we have an error here. Cannot move out of type string, not a copy slice. This is one of the good things about Rust. It helps a lot with giving error hints. So if you are an analytical person and you look at the errors shown to you, you can think of a solution, especially when you know the fundamentals. Like I said, I am still learning, so I'm just trying to make this interactive. I'm also learning more as I build more. So this is one of the projects I'm supposed to be, but I'm building it as a tutorial. So we are all learning. So this is a string. Unlike some data types like the integers that have the copy trait, the copy characteristic, string does not have it. Okay, the data is on the heap, not on the stack. It cannot just be replicated like others. So there is a method on strings called clone. So what clone does is it copies the data, like it makes a copy of the data. So we're going to call it, if you put dots here and see, you see we have clone. See, it returns a duplicate of the value. So because let me save this, and you see now you see there's no error anymore, because the value passed here is very negligible. It's not going to be a problem. This is not a big value, it's just a small text, so this works. But it's not advisable to use it when you're dealing with a large value, because copying or duplicating large amounts of data can have performance issues. Okay, so let's just do the same thing here. And like I said, we are using the clone because our data in the field is a string, the heap allocated string. So it won't work. It cannot just be copied automatically by Rust. Now we now have a function that checks if we enter the argument or not. If we did, it's going to wrap everything in a struct or a config data, all of the fields together, and store it. Right now we have not stored it. The function is going to store it if we call it and pass it those arguments. If we don't pass the arguments, we are going to have an error. Now we now have a function that builds, right? That builds this. Let's do something. we are going to, because this is where our program starts, we are going to set this up like the foundation where we are implementing the roots of the program. So we are going to use this implement for this struct config. So we want to have this function as an associated function under the config. Did I copy this? Okay, I copied it, so I'm going to remove this, right? Yes. So we want to have this as an associated function of this data. Let me save this. So if we are going to use this, we'll pass through the config and get to the build. Okay, so that's how some of these modules also work. Let's just do that. So we now have this build. Okay, let's store this the response from this build into a variable. Let's go back to our main. Okay, so let's store this as a variable, like I said. So what are we going to call this variable? We're going to call this variable configuration. Yes, let's call it config as well, config, because this is how our program is set up. Let's config equal, so whatever we do here is going to be sent here. Excuse me. So now we are going to call config, which is the struct, and then use this double colon. You see we have build. This is the one we use, build. We select it. You can type this out. Because I'm using an ID, it's easier to just move through things. So if you look at build, it expects you to pass a reference to a collection of string. So let me just wrap this with a colon and save it. So this, you say consider borrowing here, right? Because just passing this args value, this args is no longer going to be available to be used, and we might want to use it somewhere else. Okay, or we have already used it somewhere else, so it's not going to work. So what happens here is we are going to add the reference ampersand sign. So it is a borrowed value. It's just looking at the data. It's not moving anything. Now this is cleared. Now if you remember, this can fail. Let's just do something. If we want to maybe bring the fields, 5 parts. Okay, we have not stored the value. Like I said, we are building together, so this might probably be a very long video, but it's just one of those things. So this can fail. Because it can fail, we need to do something. So let's hover over build. You see it returns a result.
a type that can succeed or fail. And one of the um, functions or methods that we use on this type of data is the unwrap. So we cannot just call it and use it like that. We need to unwrap the value. Did we get an error? It's inside a package called error. We need to open it and see it, show it to the user. Did we get a success value? It's inside the OK. We need to unveil it, unpack it. I like how Ross uses the unwrap. So we're going to say dot unwrap. So this unwrap expects that whatever you're doing is always going to succeed. So like you can see, it says returns the contained OK value consuming the self value. Because this function may panic, its use is generally discouraged, right? So because we are expecting this to either succeed or fail, let's use this unwrap or else. There are others: unwrap or, unwrap error, unchecked, unwrap or default. This is where you set the default value. If you read the description, you get more information, or a default. So we're going to use this unwrap or else. It returns the success value, or we compute the error. So this gives us an opportunity to take the success or the error, unwrap or else, as the name implies. So I'm going to do a closure here. If you don't know what the closure is, it's like an anonymous function. Instead of we doing function build, you started with fn and others. No, we just do it here, and after the closure is no longer existing. So we this is going to be like an argument, right? It can be anything, but naming it error is conventional, so anybody look at the code can understand. So if you hover over error, you see it's a static string, okay, just as we expect the build to behave. Okay, so now we are going to open this here, and this is where our expression goes into. So the expression, it's not like a statement. An expression does not end with a semicolon. This is an expression. It does not return anything. Okay, it just does something. What does it do? It carries this whole value if it evaluates and put here, right? Okay, so we say unwrap this OK value, or let's get the error value inside here. So we just do print, because this is supposed to be shown to the user. We say print, this is going to be an error, right? Yes. Then this is where we put the real value. So error. So print is a statement. Okay. So we're adding the semicolon. If you notice, we are still getting an error, because this expects this config data to be here or something else, but it should still be this same kind of data. So this is where we bring in another, we call it another module called process. This is from the standard library. This module works with the current process that is running. So if you look at the description, it says this module is mostly concerned with spawning and interacting with child processes. We also provide abort and exit for terminating the current process. Good. So we want to terminate this process. If it's an error, we show the error and we terminate the process. Not like panic, which is not always the right thing to use unless you are just writing a quick program. Okay, unless you're just writing a quick program. So there is something here, exit. What is the code? Say 1. So 1 here is saying that this program stopped with an error, just like in C. I think if you look at the description, you're going to see this detail. Just like in C, 0 is success, 1 is an error. Anything aside 0 is an error. So if we save this, now we are no longer going to be seeing an error. Okay, so we have this covered. Now if this works, it will be saved here. If it doesn't work, we see the error and the process exits. So let's test this out. We have some fields that have not been used like this. Okay, so but let's just do something. So you see excuse me, we have 1, next line we have 2, next line we have 3. So I just want to print whatever we get from here. So config, the first one will be the file path. The second one will be, you see why the struct is good, because it keeps things in order. Second one will be the search string, and then the last one will be the replacement string. Okay, so let's save this. As you can see, these are no longer underlined, that they are not used. So let's run this program. Just run it with no arguments. Okay, so you see what we did there. Okay, so as you can see, we have error, invalid or incomplete argument from here. So when you call the function, this is the error it returns. But if we call it with the argument as expected, this is so let's say the file.txt, the next one is, let's say hello is the text. I want to replace it with hi, right? So it's going to print those. You see, the first file.text, hello and hi. You see, this works. If it fails, it goes off, the program terminates quietly. If it works, it shows you what you expect. Now we have this covered. Okay, we now have the arguments, right? Now what should be our next step? Since we now have the arguments, what should be our next step? Takes a file path. Let's take the file path. Let's look at the file path. Okay, this is going to be the next thing to do. We're going to remove this. It's not necessary. I just wanted to show us something. Okay, so taking a 5 parts needs us to look at the system, like the environment. Let me create a file inside here. Okay, so new file, about.me, sorry, about.text. I so hello user, is it user or viewer? This is Christian. Can't spell my name. No, this is Christian. He is a beginner in Rust programming. Christian is also an SEO specialist. Boom. We have 3 lines. Let me add something. Christian Ihechi. Okay, so we have a file, right? So we need to create a function. Okay, a function that would do this job. Like I said before, every task is supposed to be separated, division of labor, right? So let's name this function read file. Okay, so this is what the function is going to do. It's going to read the file from the 5 parts. We already have the 5 parts. Okay, so now what does this function expect? It expects you to pass a reference to a string, because this 5 parts is a string, right? But we are not going to be taking a string here, because we are going to be transferring ownership, and it's kind of constrains the whole passing of data. So we are going to say read file. What does it expect? It expects a file path. That's the parameter. And what type of data is that? Is reference to a string. Okay. What else does it need? Nothing else. Just to read the file, right? So this can also fail. So we are going to be returning a result type. Okay. Now, if this succeeds, what are we expecting? We are expecting a string. So it reads the file into a string. Okay, it's not changing the file or moving the file, it just reads the data. So if this succeeds, we expect a string, right? Yes. Then if this does not succeed, what do we expect? An error. Now, because we are dealing with reading a file, there are so many errors that we could encounter. The file is not found, the file cannot be read, directory missing, file mismatch, plenty reasons. So we don't know the exact error, but we want to get the accurate error. So there's something I learned. This we're going to have an error that is dynamic, that changes. Okay, so this is going to be inside box. This is related to the heap, a pointer that uniquely owns a heap allocation of type. Because it is going to be dynamic, it's not known at compile time, so the program does not know what is going to happen when the code is being compiled. It's during runtime, so whatever is the error during runtime is what is going to be passed here. Okay, so there is a trait called dynamic, dyn. So dynamic, the error is going to be dynamic. So this is now going to be coming from the standard library, the error module. You see, we have error. So let me just put this there. So the function signature or contract is now set. Now if you look here, it has automatically added error as well. I can make this clear sometimes, but it's not necessary. I just do it sometimes, but let me just do that here. So okay, so use std. Oops, I wasn't even looking at my screen. Use std process. We could have used exit here, but if we use exit here, that means we'll be typing just exit here. Let me show you. So exit. Okay, you see it still works, but it doesn't make sense. There might be something else named exit. You wouldn't understand where it's coming from, but if you just cut it off at the entry point, now we can just say okay, process. The process, next thing it does is exit. You see, it makes sense visually as well. So back to our second part of the whole thing. Now that we are safe, read file. Now what if we cannot read the file? That is where we always want to look at the error part first of all. So in case we are able to read it, we want it to be inside somewhere. Read the file, put it somewhere. We say let's say content, because that's the content of the file. Let content, only content or contents, content singular whatsoever. Let content be equal to, now like I said before, we're going to be using the file system. It's a module as well. So we say fs. So we use the standard library file system. So if you look at this, you see file system manipulation operation. This module contains basic methods to manipulate the contents of a local file system. So when you are solving problems, it exposes you to some of these things. That's why if you want to be a good programmer, you should be aware of so many things. If I haven't maybe done something before in the past that involved file system, I wouldn't know what to do. But like all learners, there's always a start or beginning. So we are going to be using the file system. So if you come here, you see file system is now added here. Because it's from the standard library, it just goes in automatically. But you can still do what we did. Sorry, I don't know why I like organizing it. I don't know, because aesthetics, I guess. So It's online because we have not used the imported stuff. So inside file system, what do we need to do from the file system? You see, there is something we need to do. We need to read the file. You see, there are a lot of read here, but what we want is we read the file to a string. You see, read to string. There are a lot of methods here. They have different uses. You see, rename, remove. So when you just go through this while you're learning, you see things, and when you meet problems, you now think, okay, I think something like this can work, stuff like that. Copy, exegesis, method data read. So read to string. Now, something I always do, I look at the function signature, the method signature. So read to string expects you to pass a path as reference. Okay, so now what path are we passing here? We are passing the file path. Okay, so let me just save this so you see something. You see, we did not add a reference here. It will work, but it's just like okay, first of all, file path is already a reference to a string. Okay, so if we pass it here to read to string, we are passing a reference to a string reference, like double referencing. If you hover over here, it didn't show, but there's how you're going to see it. But just get the point. If adding this here, it's going to make this a double reference. So no, you're not adding it. Now, we have not finished handling the others. There is something called, what's the name? This is it. This question mark operator. Now, this is a short form of match. Instead of saying match, instead of saying let content equal match, right? Match fs read to string. Instead of saying this, doing this, we can shorten it and say, okay, do this, read this file path to string and store the string in this variable called content. If this goes through, perfect. It will now move down to the next part of the function or the flow. But if it's an error, just immediately, don't waste time, send it up. Where are you sending it? Here. And remember, we say this error is not a particular error, it can be any error. So send it here to the error part. So if this goes through, what should we do next? We wrap the successful value inside here. You can see, if you look at here, you can see it's a string, which is what we are expected to do. Let's save it. Okay, so this function is clean, we don't have any issue. A very short function. Because of this, if not, would have been having match and cool, right? Yes. So now that we have a guy that can read now that we have a guy that can read the file paths, what should we do? We give it the file paths. Okay, go back to main. So main should just be doing the pressing of buttons. The heavy lifting is sent to every man to his own tent. Yup. So let's say let's call it content again. Content. Let content equal we're going to be calling that, is it read what? Read file? Yep, yes, read file. So it's good to use some kind of name so it doesn't interfere. Okay, so what is going to read file expects us to pass a reference to something, file path. So what is the file path we are passing to it? Remember, all the data or arguments we are getting is inside a struct. So we have successfully done that before. So we now call where the value is. We say config, right? Dot. What are we passing? File path. You see, file path is a string, and that's what this expects. But it does not expect a full string. It expects a reference to it. You see, there's an ampersand here, so this is now acceptable. Now we are going to unwrap this. Remember, it's a result type. You can fail, you can pass. So we call the unwrap, okay, or s, so that we can do some manipulation. We call the error again, and we open our closure and then print the error. Now this is the caller. You can do anything you want here. You can type whatever. So let me say application. Let me feel like a boss. Application error. Yes. So what is the error? I don't know. Now, unlike the other one that the error is typed into the code, this is not typed into the code, right? So this is dynamic. Now we also need to, I'm closing this because it's a statement, okay, semicolon. We also need to end this. If it's an error, just stop it. We shouldn't be moving. As you can remember, we also call the process and then exit the program with this code 1. Okay, let's save it. Okay, so we now have the content of the file. Okay, so let's test this out. I'm going to clear this. So let's say cargo file.text hello hi. We don't have file.text, so let's see what's going to say. Forget about this. We are going to, there are subtle errors, but if you see application error, no such file or directory, we did not put this error. It's from the PC, program, your environment, process. I'm saying a lot of things. So but this is a dynamic error. So let's say we put something that is real. Okay, so that file is called about, right? About.text. Now because this works, it's not supposed to do anything. Okay, let's print this so you see. Let's print this. It should be called content, right? Yes, content. It's a string. Okay, so let's save this. You can see content is longer underlined because it's now used in the program. So let's print this. You see, we now have the text from the file in the output. Hello viewer, this is blah blah blah. Okay, So this step is now good. And if our our argument is wrong, we get an error. Clean. The program did not panic. No, just soft. Let me clear this, and then move on. We now need to remove this. Okay, now we have the content. What should we do next? Looking at the problem, we have taken the 5 parts and found the content. What should we do next? We should look for a string inside and replace it. Then this must read the file and print the content with every occurrence of the search string replaced by the replacement string. So this function is not going to change the original file. It's just going to read the file, the content, then look for what we gave as the search string, replace it, and show us the full string with the changes. Okay, so somebody is supposed to do this job, another guy. That's where the function again comes in. So this function is going to be called what? The function is going to be named something that relates to what it does. So what does this function do? It this search and replace. Okay, yes, let's call it search and replace function. Search. I don't want to. Okay, search and replace. Okay, so this is what this function is going to be called. Does it return anything? No, it does not return anything. It only prints. Yes, it only prints, does not return anything. So we are going to be working inside the body of the function next, but let's now set the stage. What does this function need to do its job? It needs almost everything here. It needs a 5 parts. No, it needs a file, right? Yes, and that file is a reference to a string because we are not passing the original file here. Just look at the file. That's why we are using this again. Okay, it's conventional. What does it need again? It needs the search string. What are we searching for? Search. Search str, right? And search string is also a reference to a string. The final thing it needs to do its job is the replacement string. Let's call it rep. Or should I let me just call it replacement string so it's clear. Sometimes this is good. So when somebody is calling the function, maybe externally or whatsoever, what they need to pass is clear to them. Okay, just like how we see in the standard library. So I'm going to cover this. So this is the full contract. It expects this, expects this to do its job properly. So how does it do its job? Now, what we need to do is, no, let's not call this file, call it content, so it makes sense. Makes sense to the ear or to the eyes. What does this function need to do? Or how does it do its job? So it goes into the content, reads it, right? Then look for the search string, If it finds it, it replaces it with the replacement string you gave it. So now putting that into code, remember we need to print something out, right? So inside the function, let's save the string it reads and manipulates somewhere. So let's call it let's output. You can call it result or whatsoever. Let output be what? Okay. It assesses it assesses content, right? Let's see some of the methods. Content is a reference to a string. It has methods. Let's see some of the methods. So clamp. There are a lot of methods. So, but we want to use. Let's see if there's a method we can use. Yes, replace. Now, why I am able to find replace is because I know it exists. Okay, if you know something exists, let's say you are a carpenter, you know there's a tool called a hammer, you know there's a tool called a nail, you know there's something called wood, you know there's something called a super glue, and what they do, you can use them. If you have a nail and you don't know there's something called a hammer, you would probably want to use a stone or whatsoever. But once you know what's available, you know how to work with them. So yes, some of these functions, methods, I have not used them, but I've seen them. So if I meet a problem and I go through this, I might find something. There are a lot. I might find something that works for me, okay, or search as a learner. So let's call the replace. If you look at the replace, okay, let me just type replace so it moves there. You see, replaces all matches of a pattern with another string. So replace creates a new string. You can see this is going to be heap and copies the data from these strings slice into it. While doing so, it attempts to find matches of a pattern. I like how this is well explained. There's also an example, but let's just call it. And if you look at the signature here, you need a reference as the search and the another reference as the replacement. Then it returns a string. Just it's clear. So what are we looking for? From what to what? From search string. From search string. What's that search? Search string. Search string is a reference already, okay? To what? To replacement. To replacement. So let output equal content. So let's save this and see. Okay, perfect. Output is now saved. So this now we are going to print this out because this is what we are expected to do. Output. Okay, so this function very short and brief. So whatever it finds here, it puts it here as a string and prints it. Okay, so we're not dealing with any other advanced stuff here, just the main things. No return, just output. Okay, so now we are going back to our main where we press the buttons, right? So let's go back to the main. Now we are going to also save because we are calling a function, and whatever the function does, we put it somewhere. right? We can call the function directly here. What is this function even called? Search and replace. I think that makes sense. Search and replace. Search. Because this function is not returning anything, we can just call it here directly. Okay, so excuse me, you can see it says expected, right? So what are we passing? We are passing the content we have read. We believe, let me not say we believe, let's pass the content we read, depending on what is done when the program is running. It's called content, but it's a string, right? But we want it to be a reference. Okay, that's what this thing expects. You can see reference, right? So it's a string. What is going to be the search string? The search string is inside here. It's inside this our room called config. So it's also going to be a reference, right? So we say config, okay, dot search string, right? So this is also a reference, and the replacement, almost the same name, right? But we need to access it through config dot replacement str. Oops. Replacement, yes. So this is now it. Now because this is called the main, you can you as the caller can do some manipulation. Now maybe depending on what happens here, but let's test what we have done so far and see if there's any warning or whatsoever. We don't have any warning. Okay, so let's say we are passing cargo run. The file is about.txt. That's how the argument should follow, right? Yup. 5 parts: search and replacement. Okay, so about.txt is the 5 parts. What are we searching for? We're searching for Christian. What do you want to replace Christian with? I want to replace Christian with Philip. Yes, Philip. Okay, and then just print the full file with the changes. So we hope this works, unless I did something wrong, I don't know. Kaboom. Hello viewer, this is Philip. Remember, this is supposed to be Christian. This is Philip Ihechi. There's another Christian here again. That's been replaced with Philip. Okay, so but if we search for something that does not exist, let's say Amara does not exist, so let's just do this and see. It returns the full string back because it did not find what we asked it to find, so it's just sending it back. So we can handle that. We can handle that here. So maybe that's going to be an error. So the error is going to be something like it's not found. Okay, so now we are going to be doing okay, no, we are going to be doing let me just make it simple. If content content dot contains, so it contains search, right? Search string. Let's see what contains need a reference. Okay, search string is a reference to yes. Okay, if content dot contains, okay, we are putting this not sign here to negate it. If this is not true, if the content does not contain the search string, now it does this. It does this. No results found. We can actually make this return a string. Let's just make it return a string. So a string or a static error. Okay, so let's see how this works. If this is not found, it return error. So right, return error. But if this works, we now wrap output in the okay. Let's see if this goes. Okay, this works. It looks like it's going to work. So cannot find function. Okay, sorry, it's supposed to be the capital this thing. Okay, good. Now that we are saved, I like saying that. Now if there's an error here, let's go back to our main. So this expects a result, right? So if it works, we save it somewhere. There's a lot of saving. Let's output equal this. Okay, let's unwrap it. Okay, again. So I've been unwrapping a lot these days, so let's unwrap it and print the error. Okay, so error, whatever you put here, you can put anything. Just so this is going to be a reference to a string, right? Then we need to just stop it here. Okay, we exit it. So there's something I would have loved to say, but think let me not complicate the whole thing. So if we are able to get output, right, it's a string, we can print it. Okay, can print it. String output, right? Sorry. So we can print it if we're able to get it. So if it does not find anything according to this, it stops. It just no results found for query. That sounds like a descriptive error for your searched query. Makes sense. Okay, so let's see what this does. I hope everything here is okay. So if this goes okay, let's see. You see, error, no result found for your search query. Kaboom. But if this works, we get something. Okay, so if Christian, can even say H, let me use H since H is there. So we are replacing H with Philip, right? Yes, so this should work. You see, Christian, EH has been replaced with Philip. So yes, this is it. And if we want to maybe save the output to a file, we can say new file dot txt. So this does not do anything, it just saves the output to a new file. If you check your folder, you can see hello viewer, and we still have the original unchanged. Okay, we still have the original unchanged. So yes, this is us building a program from scratch. Okay, and handle the error. The program will not break just like that. So let's just do one more thing. If I round up, let's just run this. No arguments. You see, invalid. If you run it with, let's say, hello.txt, it's not complete, so invalid or incomplete argument. You can decide whatever you want to use as the error. Now that we are saved, okay, let me close this. I've done a lot of tests. We have our program running and everything. So yes, before you can do something like this, you need to get a grasp of the fundamentals, a whole lot. String, the string on the heap, data types, how to handle errors instead of using panic, and what to use, which method to use, how to break your programs into different functions. So now that this has been broken down, if we want to, we can move all of this. We can move all of this aside. We can move all of this, yes, or just move all of the functions this into a library and then call it or import it here. Then the only thing we are going to have here is this and this main. Okay, so if you look at main now, you just see it's calling and saving, so we can work with the variables. So yes, that is all for today. I'm going to be making another video, but it's not going to be this long. I don't know, but I am going to be making another video. But so far, if you watched up till this point, thank you so much, and I wish you all the best in your Rust journey. I am self-learning, okay? It's slow, but it's steady. I'll see you next time. I hope you have a great day.
Such a feeling's coming over.